All right, so in this series, we're going to get into the weeds about how objects and prototypal inheritance actually work in JavaScript. I'm going to make a bunch of bold assumptions and then hopefully back up the words that come out of my mouth with some unit tests so we can actually get a little bit of experience writing tests around some of this stuff. Ideally, when I try to make some kind of point, we'll write a test to prove that I am either right or wrong. Those tests will pass unless, of course, I have purposely written a failing test in order to make some kind of point. At a super high level, objects are a way to package up some of your state and business logic so you can use it as needed in whatever that you're building. For example, let's say we're going to build our own version of Super Mario Brothers, and we wanted to have Koopa Troopas walking around to make the game a little less boring than just Mario running across a straight level. We don't want to write each one of those Koopa Troopas like as bespoke code, like handcrafting each individual Koopa Troopa. We basically want to say like, hey, this is how a Koopa Troopa works. Particularly ones with the green shells that are kind of like dumb and just walk off the edge of a cliff. Maybe we want to define what the red shell ones look like, or act like they turn around at the edge of the ledge. We'll define what the ones with the wings look like, and the Goombas, and so on and so forth. We'll define like what these things work like in our application, and then we'll just put them places. We're not handcrafting each and every individual enemy that Mario comes across. That would be completely ridiculous. We'll define how they work, what they should do, and then we'll just put them out through our code base. That's very much how we use objects in any other kind of JavaScript application or any real like Ruby or what have you. We define this kind of prototype or this blueprint of how it should behave, and then we make instances of that Koopa Troopa and put it around our application or level or anything along those lines. JavaScript uses a thing called prototypal inheritance. And I mention that because it is a little bit different than the way that class-based inheritance works in languages like Ruby and Python and Java and Scala and all of those fun languages. The truth is, prototypal inheritance seems a little bit more difficult, but it's only because it's different. It's not actually any more difficult. It's just different. In fact, it's actually a lot simpler. In those kind of class-based languages, like you have this like ephemeral like blueprint of a given object, and you've got to figure it out. All prototypal inheritance is this idea that any object can inherit from any other object. It doesn't have to be a special class. It could be a thing that we treat like a class, but it doesn't necessarily have to be a class. It's just any object. We ask that object for a given property, whether that's a value or a method. We check that object. If it doesn't have that object, or it doesn't have that property rather, it will just simply check whatever object it inherits from. So it's basically just a lookup chain to figure out how to either return a value or do a thing, and that's it. The old saying is that basically you could implement classes using prototypal inheritance, but you can't implement prototypal inheritance using classes. And we'll actually see that that is true later in this series. For now, we're just going to kind of take it as a given. One of the cool parts of JavaScript is that it's super easy to whip up a plain old JavaScript object. And we have a literal syntax for it. What does a literal syntax mean? That just means that like we can type some funny characters and have a version of it rather than having to type like new object. So we could say const object, and I could do something like this. But I don't have to because we have a literal syntax, and I can just do this instead. And so this is what we would call an object literal. All right, it is an object. It's the same as typing in a new object. It will inherit from object, and it will be an instance of objects. Let's actually try that out. So we'll expect that our object literal, and we'll expect that it is to be an instance of object. And you can see that in this case, our little object literal, which is just two curly braces, is an instance of this capital O object that exists in JavaScript. We know that they are a much lazier, let's use the word convenient way to make objects instead of writing new object all the time. We know that they don't come with any properties and values unless we define them in between those curly braces. We're going to find out that they all inherit from object prototype despite being instances of object. And later on we'll get into like what the difference between a prototype that you inherit from and being an instance of something is, but for now we're just going to go with it. An object or object prototype is just all of the things that are common of a regular object in JavaScript, just like the kind of prototypal Koopa Troopa that we've been dealing with earlier. So now, despite the fact that all objects are instances of the capital O object, it is not the case that that capital O object is the prototype in which all those objects inherit from. First, we're going to prove the case that it is not the prototype of a given object literal, and then we'll go ahead and figure out what exactly the real prototype of an object literal is. So we'll start by kind of disproving my first statement that object is not the prototype of an object literal. So we'll say that we expect a given object that we spun up, it does not have that, it does not have capital O object as prototype, which raises the question of how do we find out what the prototype of a given object is? Well, their capital O object actually has a method on it called getPrototypeOf. GetPrototypeOf will take literally anything, or ideally an object, right? So in this case, our object literal, and it will return to us the prototype of that. So we're going to say that we expect it not to be capital O object. We'll go ahead and we can see that our tests pass. Instead, we want to say that object.prototype, which makes sense, is the prototype for all of the objects that we create with an object literal. So let's test out that assumption. We can expect that the object.getPrototypeOf for the object literal, we can expect that it is object.prototype. Yeah, there we go. Let's go ahead and we can see that our tests once again all pass. Object.prototype has a few methods on it, like hasOwnProperty, isPrototype of, toString, and value of, along with a few others that are available to all objects that inherit from it. So now it stands to reason that while our brand new object does not have a property called toString, because it inherits from object.prototype, it should still have access to this toString method through the prototypal inheritance chain. Let's see, like, if it exists at all. So we'll go ahead and we will expect that our object literal toString is not to be undefined. We'll go ahead and we can see that that test passed as well. So while our object literal, as we can clearly see on line 18, does not have a toString property, it inherits it from object.prototype. Another fun method that we get from object.prototype is this thing called hasOwnProperty. And hasOwnProperty is basically a little helper method that checks for you, all right, does this object have this property or is it inheriting from it? So hasOwn, so basically, if it is a property of that object, it'll be true. And if it's actually inheriting that property from somewhere, we'll end up with false. So our hypothesis here is that the object literal on line 23 in this case does not have a toString property, which makes sense, and it inherits it. So it should not have its own toString property when we go ahead and write a test. Our hypothesis here is if we look on line 23, that object literal does not have a toString property. And so hasOwnProperty should return a falsy value. If we see, like, does this, we can see that it has a toString because we can, in the previous test, there it is. However, the object itself must be inheriting it, or the object literal must be inheriting it because it does not have it on itself. So we'll just go ahead and try this out. So we'll expect that object literal hasOwnProperty toString, which it definitely has given the previous test, to be falsy. And we see that this test passed as well. We can get a little bit more meta here. We'll just copy this test. That it also doesn't have a hasOwn property either. So we'll go ahead and we'll just, we can see it is also the case that hasOwnProperty returns false as well. Object.prototype is, again, it's just an object as well. There's nothing special about it. The only difference is it is the object that holds on to all of these toString, hasOwnProperty, value of, isPrototype of, some of the ones we saw when I showed the console earlier. Unlike a regular object literal, it should have a toString property, but it should actually own that property itself, although those object literals just inherit from object.prototype. So let's prove out these three assumptions: that it has a property called toString, that it owns that property called toString, unlike the object literals, and it also owns hasOwnProperty. So this will be a little bit different from the object literals that we saw earlier. So we can expect object.prototype to string to be defined, right? We can expect that object.prototype has own property to string to be truthy. I'll just take that, and we'll also assume that it has own property as well. So let's try out these 3 tests, and we can see that all 3 of them pass, which proves out some of our assumptions. So what did we learn? We learned that the easiest way to think about prototypal inheritance is that it's basically a system where we check the object to see if it has a property. If not, we check another object, and so on and so forth until we get to the end of the line to see if any of those objects along the chain have that property. So it's a way for objects to use code or delegate to other objects that exist in our application. In a lot of cases, this could just be object.prototype, which out of the box serves as the prototype for most of the objects that we will spin up. Any object can be the prototype for another object, but a lot of times we make special objects that serve as the blueprint for a class or kind of objects. Object literals are just shorthand for making new instances of object, and those objects inherit from object.prototype. The prototype for all objects is object.prototype. All objects made this way using object literals will inherit from object.prototype. And object.prototype has some helpful methods on it.